when we learned about different types of thermodynamic processes like isothermal, adiabatic, and all those things, there are two more types of processes, or you can say it's just one split into two. Okay, technically two. They are reversible process, irreversible process. Now, reversible process, according to physics, what is the definition of a reversible process? See, look at the definition. Here, the process, after it comes back to its original position or original state, then no other thing, that is the system or the surrounding or whatever the position in the universe, that should not be disturbed because of this whatever action we have done. Okay, now see, we can do a lot of examples for this one. Okay, like slowly changing the temperature of water, boiling water, or slowly changing the temperature of the ice where it is converting from ice to water, something like this. All right, there are two conditions, more like you can say essential conditions for this reversible process to occur. The first one is that the process has to be a quasi-static process. That means it has to be very slow, not just the beginning and the ending part. Each and every step of the process has to be a quasi-static process. It's infinitely slow, then the reversible process can occur. Okay. The second condition or second criteria, whatever we have for the reversible process to occur, is that there should be no dissipative forces like friction or viscosity or whatsoever it is. All right. This basically is the second condition required for the body to be in reversible process. Body in the sense system, guys. Fair enough? Now, these two are the necessary conditions for the system to be in reversible condition or reversible process condition. Practically speaking, no process is completely reversible. We can only approximate, we can say that it's almost reversible, but no process in the universe is completely reversible. There's always some sort of a change either in the system or in the surrounding. Okay, so this is where we introduced you to the concept of irreversible process. Here, irreversible process meaning what? Something which does not going to satisfy the above two conditions. That's basically an irreversible process. Okay, now we can give so many examples. Pretty much everything we see, everything we do, they're all irreversible process. Okay, now we'll start with easy ones. Okay, now easy ones, decaying of things, like decaying of fruit or maybe a vegetable, whatever it is. Decaying of organic matter is actually an irreversible process. All right, and maybe boiling of water also you can take. That's also a non-irreversible process. Okay, so we can give a lot of examples for irreversible process. Fair enough? Now we have two processes, reversible and irreversible. Reversible comes around in the same. Irreversible goes and just goes off somewhere. Isn't this are irreversible process? So along with the four thermodynamic processes, you also have these two. And now these two, we are not talking them as, or we are not taking them as thermodynamic processes. These are just two processes in which one returns to the same position where the system and the surroundings are not disturbed. Another one is not going to comply to any of these things. That is basically irreversible process. So along with those four, we also have other two, that is reversible and irreversible process.